In this session, we'll study how there is a rotating magnetic field is producing in an induction motor. We know that the induction motor consists of two parts. One is the stator, the other one is the rotor. Also, we know that in the rotor we have got the conductors are placed, they are short circuited on either side, either on the rotor itself or brought outside and short circuited. In the stator circuit, we have got a three-phase winding. In the stator, we have got a three-phase winding. These three-phase winding are connected to a three-phase supply. These windings are excited by a three-phase supply. When the supply is given, the current starts flowing in all the three phases. Also, we know that whenever there is a current is flowing through a conductor or a coil, it is producing its own magnetic flux. Therefore, you have got a three windings and there are three currents are flowing in each winding. They are producing their own fluxes. Then all these fluxes interact each other and they are producing a rotating magnetic field. How exactly we are getting a rotating magnetic field, that we'll study now. We know that in the stator we have got three windings of an induction motor. They are displaced 120 degree. That we have got a stator here. There are three windings R, Y and the B. They are displaced 120 degree. And also we have got a rotor. On that we have got a rotor conductors. They are short circuited. Then these three windings are excited by three-phase supply. A three-phase supply is given to the three windings. Then when the three-phase supply is given to the stator winding, the currents I1, I2, I3 they are flowing in the three windings. We know that we are giving a AC voltage here. The resulting current which is flowing through all the three windings, that is R, Y, B windings, is also alternating in the nature. When the current is flowing through the winding, they are producing their own magnetic flux. These magnetic flux are also alternating in the nature because you are applying the AC voltage. Because of the AC voltage, you have got the AC current is flowing in the winding. Because of the current is flowing through a coil, they are producing their own magnetic flux. The flux is also alternating in the nature. That is, the current in a winding and the magnetic flux produced are also displaced by 120 degree. That is, we know that all these three windings are displaced by 120 degree. The current I1, I2 and I3 are also displaced each other by 120 degree. Then the flux produced by I1, I2, I3 is also displaced by 120 degrees. Therefore, the flux phi1 is produced by because of the current I1. The flux phi2 is produced by I2 and the flux phi3 is produced by the I3. That is, I1 is the reference current, then I2 is lagging by I1 by an angle of 120 degree, I3 is lagging I2 by an angle of 120 degree. Similarly, the flux phi1 is a reference, then phi2 is lagging phi1 by 120 degree and phi3 is lagging phi2 by 120 degree, or the phi3 is lagging phi1 by 240 degree. I am representing these phi1, phi2, phi3 vectorially. That is, the instantaneous flux produced by three windings be given by phi1, that is the first one is taken as a reference, phi max sin omega t. It is a sinusoidal flux because the current I1 is sinusoidal. Therefore, what I am drawing here is the phi1 is a reference I am drawing here. Similarly, then I have got a next, the flux is phi2, that is given by phi max sin omega t minus 120. That is, the phi2 is phi max sin omega t minus 120. That is, phi2 lags phi1 by 120 degree. Therefore, it is 120 degree lag if you are going in the clockwise direction. then there is a phi 2. The third flux is the phi 3 lags phi 1 by an angle of 240 degree. Therefore, you have to draw the phi 3 lagging phi 1 by 240 degree. Therefore, this is a phi 3 which lags phi 1 by 240 degree. Therefore, there are, because of the alternating currents are flowing in the three windings, three alternating fluxes they are producing. They are also displaced by 120 degree. When these three fluxes they are interacting, that is phi 1 is producing, phi 2 is producing and phi 3 is producing, these all three fluxes they are interacting each other, they are producing the rotating magnetic field. That is why I am writing here the resultant flux produced by which rotates in space. That is, because of the interaction of phi 1, phi 2 and phi 3, there is a resultant flux is producing, that is rotating here. That is the resulting flux which is produced by phi 1, phi 2, phi 3, which is rotating in the air gap. How exactly the resultant flux is rotating the air gap, that we will study now. At this particular slide, we are seeing that there are three windings in the stator winding of the induction motor. These three windings are supplied by a three-phase supply. Because of application of the voltage to the three winding, the current starts flowing in the three windings. They are alternating in the nature. Because of the current is flowing through the windings, they are producing its own magnetic flux, that is phi 1, phi 2, phi 3. They are displaced 120 degree with each other. When these fluxes are acting on a rotor, they are producing a resultant flux that has got a constant magnitude, however it is rotating. How exactly this resultant flux is rotating, that we'll see. Now we have got a resultant flux produced by the interaction of the three fluxes phi 1, phi 2 and the phi 3. Then if there are three vectors are there, if you are interested in the resultant flux and its the direction, what you have to do? You have to resolve phi 1, phi 2, phi 3 into the horizontal component as well as the vertical component. Then you have to find out the resultant flux as well as the direction of the resultant flux. The same procedure is followed here. I have got a three vectors phi 1, phi 2, phi 3. Then I am representing this phi 1, phi 2, phi 3 because these are displaced by 120 degree each other. Then what I want is, I want the horizontal component. The horizontal component is the x component of all the three vectors. Then if we are seeing the vectors here, the x component of phi 1 is phi 1 itself. However, you have to find out the x component of the phi 2 as well as the phi 2, which is acting on minor x axis. See here. Here it is 120 degree. Between these two is also 120 degree. Then this angle what we are getting is between the reference axis and the phi 3 is also 60 degree. Between phi 2 and the reference axis also it is the 60 degree. Now I am resolving this. See here, I am resolving this. First I am taking the resolution of phi 2. What I am getting is, it is a x component of phi 2. Then if you are considering this triangle, then you have to apply the function here. What function you are applying? It is the adjacent side. It is what I want is this. It is the adjacent side divided by what I know is hypotenuse. I want the adjacent side. This angle is 60 degree. This angle is 60 degree. Therefore, what function I am applying here? It is I am applying the cos function here. Therefore, then it is the x component of phi 3. Before that, what I am getting is the x component of phi 2. Then I am also resolving the x component of phi 3 also. Therefore, what I am getting here is, what is the x component of phi 1? That is a phi 1 itself. Then what is the x component of phi 2? That is phi 2 cos 60 is the x component of phi 2, but it is acting in the negative direction. Therefore, I am taking it is a phi 2 cos 60 because this angle is 60. Then what I want is this, and it is a hypotenuse minus phi 2 cos 60, what I am getting here. Then Similarly, once again you consider this triangle. Once again, this is what I am interested, that is the x component of phi 3. Then once again you are applying the cos function, then what I am getting is phi 3 cos 60. Then ultimately what I am getting here is, it is a phi 1. The cos 60 is common in both the terms, therefore I am cos 60 I am taking the outside. Then what I am getting is phi 2 plus phi 3. Then what I am doing here is, I am substituting the value of phi 1, phi 2, phi 3 in this equation. Phi 1, phi 2, that is phi max sin omega t, phi max sin omega t minus 120 and phi max sin omega t minus 240. I am substituting here in this equation, and after substituting then I am applying the sin a minus b formula and I am simplifying. Ultimately the horizontal component what I am getting is 1.5 times phi m into sin omega t. That is what you have to do. You have to substitute all these phi 1, phi 2, phi 3 and you have to simplify this. After simplification what I am getting is 1.5 times phi m sin omega t what I am getting. Similarly, you have to go for the vertical component. Once again I am drawing the phi 1, phi 2, phi 3. What I want is the y component or vertical component. The vertical component of phi 1 is 0 because it does not have its y component. Only the y component has got phi 2 and the phi 3, that is this value and this value, that I will show you here. That is, once again this angle is 60, this is also 60. See here, I am resolving the phi 3 into its y component here. This is y component. Similarly, this is nothing but this value, this value. Similarly, this is the y component of phi 2. It is same as this value. What I am considering is this triangle. This triangle and this triangle. Once again this angle is 60 degree. Then what I want is this component is opposite side, therefore I am applying the sine function for this as well as this. Therefore the vertical component what I am getting is, here is vertical component of phi 1 is 0, vertical component of phi 2 is this value, that is phi 2 sin 60 because it is acting in the minus y axis, therefore it is minus phi 2 sin 60. And here what I am getting here is in the positive direction, this is the value of the y component of phi 3, that is phi 3 sin 60. Therefore if we are once again making here, it is a phi 3 sin 60 is a common, phi 3 minus phi 2, it is a phi 3 minus phi 2 into sin 60. Once again what I am doing, I am substituting the value of phi 2 and phi 3 in this, and once again I am applying the sin a minus b rule and simplify. Then the resultant vertical component what I am getting is 1.5 times phi m cos omega t. Then what I want is the resultant of these two. Then how we have to find out? This is a horizontal component and this is a vertical component. If you are adding these two vectorially, then what I am getting here is the resultant. The resultant how we are getting? And is once again it is a right angle triangle. You can apply the Pythagoras theorem. It is a horizontal component square under square root horizontal component square plus vertical component square. What we are getting is the resultant. Therefore the resultant flux is under square root horizontal component square plus vertical component square. Then if you are substituting and if you are finding the resultant, what I am getting is 1.5 times phi m. That is the resultant, the flux what I am getting here. Then if you are observing this, it does not contains any time factor here, that is omega t or t is not appearing in this particular equation. Means the resultant flux is the independent of time. It is independent of time. Means at any instant of time the resultant flux remains the constant, that is 1.5 times the phi. Therefore I am representing phi r is equal to 1.5 times phi. Then how to find out the direction? That is the direction what I am getting here is the tan theta is equal to vertical component divided by horizontal component, and is a vertical component divided by horizontal, that is opposite side divided by the adjacent side. Therefore, if you are putting the value here, what I am getting here is cot theta, cos omega t divided by sin omega t, cot theta. Cot omega t you have to convert into tan omega t by omega t minus 90. Therefore, both sides we have got a tan function that can get cancelled, that is theta is equal to 90 minus omega t. Means what I am getting from this discussion here is the resultant flux of a three fluxes phi1, phi2, phi3, they are displaced by 120 degree each other. The resultant flux what I am getting is 1.5 times its maximum value, which is a constant, it is independent of the time. At the same time, what I am getting is the theta, that is the direction, is given by 90 minus omega t. With this, then we'll see how the rotating magnetic field is producing. That we'll see here. That is theta is 90 minus omega t and phi r is equal to 1.5 times phi m. That is the resultant flux is constant irrespective of the time. As the angle changes, as the time changes, angle changes, then how exactly the vector moves. That is theta is 90 minus omega. Theta is the angle made by the resultant flux. Okay, we'll consider different cases. When omega t is equal to 0, when the omega t is equal to 0, what is the theta? Theta is 90, that is the corresponding to the point A. That is here. That is, it is theta is equal to 90. How we are representing A with a 90? With respect to reference, 90 is, it is in the anti-clockwise direction. At omega t is equal to 0, you have got a resultant flux is phi r 1.5 times, it is at 90 degree. The next I am considering omega t is equal to 90. If the omega t is equal to 90, then what is the direction? Theta is equal to 90 minus 90 is theta is equal to 0 corresponding to B. That is what I am getting is the resultant flux is at the point P, means it is theta is equal to 0 because reference axis 0. Means the result, when omega t is equal to 0, the resultant flux is at this position, and when the omega t is changing from 0 to 90, it is moving from A to B. Now I am considering omega t is equal to 180, means what we are getting is minus theta is equal to minus 90, therefore it is corresponding to the point, the C here, the corresponding to point C here. Means when omega t is changing from 90 to 180 degree, and it is the resultant flux is moving from position B to C, that is from B to C. Then the fourth one I am considering when omega t is equal to 270, theta is becomes 180 degree, that is corresponding to D, that is 1.5 times phi m. Then it is moving from C to D. Then the cycle repeats. What you are observing is, as the value of the time or the angular displacement goes on changing, then the resultant flux is changing its direction, means it is rotating with a constant magnitude of 1.5 times the phi m. Means what we are concluding here is, when the three-phase supply is given to the three-phase winding, the alternating current will flow. Because of the alternating current, alternating flux are producing in all the three windings. These three fluxes, they are interacting each other. Because of that, there is a resultant flux is producing, and it is the rotating. That is what we are observing is here. Therefore, the conclusion is that three-phase currents of the balanced supply system produces resultant flux of a constant magnitude in air gap of the motor. The magnitude of the resultant flux at every instant of time remains same, that is 1.5, and this resultant flux is rotating with the speed of synchronous speed, that is 120 f by p. This is how there is a rotating magnetic field is producing in the three-phase induction.